Hi everyone, welcome to WeAreDevelopers. Are you excited? Cool, that's the right energy. Um, 7 years ago, I was on a plane. The plane was direct to Tokyo, London to Tokyo, 12 hours of flight. As you can imagine, long flight, a lot of time to think. Luckily, I was in business class. And that flight changed completely my life because I started to think how create distributed systems for frontend. And that's where we are here today. 7 years later, we are here talking about what I have learned about microfrontends and how to make the best use of them. One thing that I learned when I joined Amazon was this. So directly from Andy Jassy, our CEO, that there is no compression algorithm for experience. And therefore, what I want to do is sharing my experience today with you and try to provide you all the insights for designing a successful microfrontends application. My name is Luca. I'm a principal solution architect in AWS, an international speaker and an O'Reilly author. And let's start first, before dive deep into the topic, about the benefits of microfrontends. In the last few years, I spent a lot of time, a lot of talks, wrote blog posts, books, and everything about microfrontends. And what turned out to be very useful in the front-end world is the incremental upgrades nature that is available in microfrontends. If designed properly, we can independently deploy our microfrontends without too much coordination, if no coordination at all, even better. And we can take our own piece as a team for deploying our application or part of the application in front of our users. The second concept that shines is the concept of decentralization, and that is for any distributed system, not only microfrontends. Decentralization means that every team should have skin in the game. The reality is very often, unfortunately, I've seen organizations that are extremely centralized and they're trying the journey into distributed architectures. And it's not easy because unless you start to change and shift your mindset and empowering the developers to take their own decision inside certain guardrails, it's going to be difficult. And guardrails is the key word for the tech leadership because the tech leadership should start creating these guardrails to suggest a bunch of techniques, tools, and raise the best patterns that they have seen inside the trenches for all the teams. The third thing is reducing the cognitive load. If you're familiar with the team topologies book, you probably have read about the concept of team cognitive load, where usually in a monolithic architecture, you can jump from, I don't know, the acquisition domain or payment domain to the catalog domain, and you need to understand everything. So there is a huge effort for the team to maintaining that code base across the entire system. So with microfrontends, we are trying to reduce that. We have just a portion of the domain, like domain-driven design suggests, and we can master it. We can become expert, and that will help us to, let's say, fast-track certain decision, fast-track certain deployment, but moreover also have new developers joining our teams and quickly contribute to the code base. Last but not least, architecture is strictly related to organization structure. Never forget that. And I think it's important to highlight that when we are looking for a distributed system, we are not looking only to technical characteristics. We are looking also, and sometimes more importantly, on the organization structure. So having distributed system, including microfrontends, will allow you to spin up new teams and scale your organization properly. With that all said, let's focus on the anti-patterns. We always say what is good for microfrontends, let's see what is not. Those anti-patterns are basically what I have learned in several engagements with the customers that I follow in the last few years. And I've seen some mistakes that were happening over and over and over, so I decided to collect them. Let's start with the first one, and probably the most common one. I call it the yin and the yang, or the difference between microfrontends and components. Let's start with the components. Let's take the most simple component in the world, the button. And usually in a button, if we want then to reuse everywhere, we start to have a button that has a label. Great. A few weeks later, new requirement. Now the button might have also an icon. So you want to have the possibility to decide based on the context if the button has a label and an icon or not. Then suddenly new requirement kicks in. Change border color. So I want the possibility to change the border color because in certain occasion or in certain portals, this button should have this difference. Or different rollover animation. I want to instruct my button to change the specific characteristics. Auto size dimension. You introduce internationalization or localization, and you want the possibility that the button auto resize based on the dimension of the label. Last but not least, you want to use the button also on some forms, so you want the possibility to disable the button out of the box. So as you can see, there are a lot of characteristics of this button. But there is a key thing to understand here. The button has all these functionalities. It's exposing a very large API with a bunch of different, let's say, possibilities for the container. But the reality is it doesn't own the domain. The reality is the container of this button knows how the button should behave. And therefore, we are not in front of a microfrontend. If you take my definition of microfrontends, I define as a technical representation of a business subdomain with independent deployment. They might use same or different technology choice. We will get back to that later. And they should minimize the code share, reducing the external dependencies, and a team should go to end the microfrontend. Now, the things that we care for the difference between microfrontends and components is this one. So the technical representation of business subdomain. If you're familiar with domain-driven design, a subdomain is just a portion of the complex system. Let's pick Netflix, for instance, probably everyone knows it. So Netflix is not just video on-demand streaming platform. It's also a payment, it has also a possibility to a payment gateway. You can contact customer support. You can do a bunch of things that are represented by different subdomains. The other thing is independent implementations. The moment that you find yourself to deploy two microfrontends constantly together and coordinating the effort, probably you need to go back to the whiteboard and understand if they are really microfrontends or not. So let's take a microfrontend now. So how the microfrontend differ from a component? First of all, is independent. I can dump it in a place and I can go my own pace. I don't have to coordinate with anyone, and that's great. So if there is a new release, it's my effort, it's my team effort to handle that. It's domain aware. It knows how to behave. I don't need to have a container that is telling me, okay, you need to disable this, you need to do that, and so on and so forth. So the API layer start to become very, very small, and that is a great heuristics, by the way. So if you see that your API start to grow for allowing more possibilities to your microfrontend, again, you are transforming that element into a component. You need to define input and output clearly. We will see later a good technique for defining them. And finally, they tend to not be too extensible because they are domain aware. They know how the things are working for the specific domain. So the moment that you find yourself in a situation like that, probably you don't have too many microfrontends. You start to have too many components. And therefore, you need to ask yourself, are you designing microfrontends or component? Second anti-pattern, the Hydra of Lerna, or the multi-frameworks approach. That is something I read so many times on social and blog posts. Microfrontends are created because we can use finally multi-framework approach. I have a question for you though. How many UI libraries or framework would you use in a single page application? I hope that the answer is one. I see some ones here, so great, that's the right answer. Why you would do different with microfrontends? Despite you can, it doesn't mean you have to. And therefore, yes, multi-framework approach is a thing in microfrontends, but for specific use cases. Dealing with legacy system, maybe you have a legacy system and you want to leverage the possibility to independently deploy your microfrontend and create value for your customer. And therefore, you want to have your legacy system living alongside the microfrontends implementation. That's a valid way for a multi-framework approach, because you know upfront that we stay there for a short amount of time, hopefully. Migration to a new UI library. Think, for instance, you want to update from, I don't know, Angular to React or vice versa, up to you to decide. And you want to do that iteratively. That's a good way to handle that. Last but not least, and I didn't think at the beginning about that, but it's a reality. There are some large organizations are acquiring new companies. They want to immediately generate value for the customer, but inside the same umbrella. Therefore, they're using microfrontends for, meanwhile, they are replacing or rewriting the entire system. Therefore, use multi-frameworks approach when appropriate. Don't optimize your architecture for them. And I have seen companies doing that for providing freedom to developers. The problem is we are not writing code for developers, we are writing code for the users. So we should think about that. Next anti-pattern is the Swiss Army knife. And as you can see, I'm not that young, as you can imagine from my beard. I'm a big fan of Unix, and I like the fact that you do one thing that is pluggable, composable, and you can and you do that thing very well. So let's imagine this scenario: greenfield project. So we decided to go with microfrontends, large team, large organization, that's the way to go. So first you create a container, client-side rendering application, and you have a microfrontend A that is developed. And microfrontend A basically is just a portion of the application. Then in another part of the application, you have two microfrontends that have to live in the same view together, because they are, maybe think about my account that shows the user details and the payment that could be easily two different domains. But they live together, so for the user is a unique page. You need to figure out how to communicate together, and there are a bunch of possibilities over there. And then suddenly you also have to decide how you're going to store the token between microfrontends, and usually in that case you can use local storage, session storage, web worker, or even a cookie. So there are a bunch of things that you make the decision. Obviously, if you have followed me in the past, I created this mental model called the decision framework that allows you to navigate through those decisions and pick the right one for your context. All great. We go ahead with the development, and everything is successful. Teams are empowered, they are developing at an insane rate, all great. Suddenly, acquisition comes. And there is this legacy editor that is awesome from what the business told us, and we need to integrate with our application. Okay, great. So we need to implement that. So the first thing that we are thinking is, okay, I take this legacy editor, no clue how was developed, which library are inside, too long for refactoring because it's a huge project. Therefore, we need to generate this value. Take an iframe, you wrap it in an iframe, you isolate completely, job done. Not really. The reality is currently you have an application shell that is containing your microfrontends and is communicating in different ways using an event emitter for communicating with the rest of the API. So now with iframes, you need to think something else. You need to think maybe I use post message and then I create the logic into the application layer for optimize that. The problem is that I have with this approach is that if today is the legacy editor, tomorrow will be something else, and we start to easily create code that became quite messy and at some point has to be removed with higher risk for what we are doing. But thanks God, in the microservice world, there is a fantastic pattern called anti-corruption layer. And the anti-corruption layer is used for trying to shield what is the outside world from the inside world. So in this case, you could create a microfrontend that contains your iframe and communicate through post message with the legacy editor, and then is sanitize the communication with the rest of the application very easily. So it could be that is a standalone legacy editor. It could communicate in the same view with other part of the system. There is no problem because now you have an anti-corruption layer that is wrapping that. It's great because it's aligning your architecture decision, this pattern. So it allows you to avoid to write code that will be thrown away in a few months' time or in a few weeks' time. And in this way, you will be able to maintain your code properly. And also, it's ready for the future. The moment that you will finalize the development of the new legacy editor, you can easily swap it as long the contract between the micro frontend that contains the iframe and the application shell remain the same, easy to swap it. So when you are in this kind of situation, spare the application shell code base and try to use this kind of solution for, let's say, shielding the code in a way that will allow you to be ready for the future. Oh, this one is fun. Dependencies. I know that everyone loves dependencies in JavaScript. So my question is, do you really need that external dependency? Let's try to play this scenario. So I worked in quite a few companies in the last few years. And there are some scenarios that I remember, unfortunately regret certain decisions, but you know, it's all part of the journey that we are. And this is one of them. And with the distributed systems, it can be extremely tedious. Imagine that you have multiple micro frontends, and at some point you realize, oh, I have a lot of code to share between my micro frontends. So I create a core library and the core library team. Okay, so let's play this scenario with the core library team. So the core library, first thing that happens, first release 1.1.0 is there. Every micro frontend starts to implement that. Unfortunately, at some point, we need to release 1.2.0. It's a minor change, so no IP breaking contract in the API. If we use SAMVer properly, should be fine. But the first question I have for you, as you can see here, you have an external dependency, and we want the team to work independently. Therefore, you need to be comfortable to have a team that is implementing the new version and others that they're not. Maybe if it's a minor or bug fix, can be okay, but maybe if it's a major, it's not. The other problem I have seen, though, is when you don't invest much time on the governance part of your external dependencies and the CI/CD or the automation part, usually tends to appear here and there inside the organization because we are independent, the core library extended, or let's say, taking the core library that does 90% of what I need, but not the 20% that I really need now. So I cannot wait for the core team because it's swamped with work to do. What can I do? Well, I create my code. What's the problem? So now we have core library 1.1.0 that is released. Micro frontends A and C are using them, no problem at all. And also for the core library extended, first version is using 1.1.0, all great. But what happens if we have version 2.1.0? So now we have a breaking change on the API, right? So the other micro frontends might or not upgrade immediately to that. But what happens to the core library extended? Unfortunately, in my experience, there is always a delay that, especially when you don't use composition and you use a lot of inheritance. So you rely deeply on the functionality of the core library and the API of the core library, and in reality, that is basically an issue. If it's one library, fine, we will survive. What if we have tens of them and we have a very large organization? So that scale very quickly, and therefore you need to be careful when you decide to go with to work with multiple libraries. Now, it's obvious that in a distributed system you need to create certain consistency. If for microservices you want to use logs and I don't know, observability, for instance, in general, for micro frontends you want to use a design system. You want to use maybe some specific things that are shared across micro frontends, and that's fine. But always try to think this problem and try to choose composition over inheritance. It's an old, let's say, suggestion, but bear in mind, when you are in distributed system and independent teams, you are externalize some code, the risk of bubbling here and there new libraries shared across two micro frontends and not the others, and maybe not even aware of that, is a problem. Especially because it's going to bite you in 6 months, 1 year, 2 years, whatever. Oh, the next one is fun. Return ticket, please. That is something that microfrontends introduce as very easily in our decision. So let's assume, oh yes, what we are going to talk about is unidirectional data flow. So let's assume that you have this situation. Maybe if you're familiar with Module Federation, you recognize the name. If you're not, let's assume that we have a host or a container, and you have a remote or a microfrontend. So in this case, usually a microfrontend is loaded inside the application shell, great, inside the host in this case. But if we develop our own microfrontends, let's say application in terms of framework, or you're using certain frameworks that are already available, you can have a bi-directional sharing. So now it's a microfrontend. Think that you have 10 of them, hundreds of them, and you're sharing from the host to the rest of the microfrontends. What's going to happen if we change the host, for instance? Unless you have a very strong testing strategy and a very solid way to handle this, it might be a car crash very quickly. Let's go back to the history and let's see what we have learned with that. How many of you heard about Flux? Okay, a few of you. So Flux is probably one of the first state management libraries that were out from Facebook back in 2014, if I remember well the year. And the groundbreaking thing that was leveraging is the idea of unidirectional data flow. So the event was going from one point to another one. Every single entity inside this library has a specific thing to do, the store, the view, etc. And it was quite clear to develop that. And from there, everyone leveraged this pattern. Everyone, not only in the web community, but also in the, for instance, also the native community. This is MVI, it's Model View Intent. It's another unidirectional data flow architecture that is used in Android. It's also available in JavaScript if you're familiar with Cycle.js. I worked with that for a while, and it is quite interesting approach. Fully reactive, very nice. So what we have learned with unidirectional data flow, that is easy to debug and less prone to errors. That sounds great, right? So we already have the complexity that is inheriting distributed system nature of microfrontends. We already have a lot to think about the governance part, communication between teams, and logging, debugging, UX, whatever. So if we can simplify our life, why not? So ideally, try to avoid bi-directional sharing unless it's strictly necessary. There are certain situations, I would say, that you might want to do that, but it should be an exception, not the rule that you're optimizing for. Oh, another biggie one. Relax is just code. I heard that so many times. Unfortunately, we often forget the link with the organization structure and our code. So, one of the questions that I heard so many times is, shall we create a global state for communicating with my microfrontend that are living in the same view? Okay, let's analyze that. So let's assume that we have a global state, and now microfrontend A is obviously reading, writing in a global state, the same for all the others. Suddenly there is a breaking change. Now the team responsible for microfrontend A that changed the API for a specific part cannot deploy because they need to wait for the others to be ready. That is called design time coupling. In microservices, it's an anti-pattern. So it can be also on the microfrontend as well. So how can we create loosely coupled entities that are highly aligned? Events. So one of the architecture, or better, a design pattern that we have learned is that allows us to do that is a pub sub pattern, or publish subscribe pattern. And this is a way for the producer to dispatch an event, and the consumer, if interested, they will pick it up and react to that and do whatever they want. This way, make a change, dispatch an event. If someone is interested, great. If someone is not, it's a problem. Then there is another challenge that is around, let's say, create visibility of those events. And usually one thing that I recommend is always have, for now, an idea of writing down all the events that are bubbling inside the view so everyone can plug it. But within events, it's way easier that you can go ahead and deploy independently because you are more mindful of what you are sharing. There are different type of events that you can dispatch there. Therefore, try to embrace loosely coupled but highly aligned microfrontends, because otherwise it might be a challenge. The next one is this one. So let's hammer the APIs. That's another anti-pattern. I didn't expect to see that often, but instead I did. So when we have multiple multiple microfrontends calling the same API. This is a scenario. So we have 4 microfrontends all together that are living in the same view, and then suddenly, you have the 2 at the bottom that are calling exactly the same API. Okay, so we have distributed system on the front end. It's likely, I cannot say 99%, but it's very likely that the distributed system is also on the back end. Let's try to see what the backend developers has to do in this case. So we have 2 microfrontends calling the same API. Usually microservices, you tend to have to expose all your API. You have an API gateway or load balancer, usually an API gateway, that centralize, often, not always, the authorization service. So in this case, we have 2 microfrontends with the JWT bearer token that are, let's say, authorized by at the API gateway level. And then, all good, everything is working. And finally, we reach our API 1. It's a distributed system. So potentially, API 1, for any given reason, can call other APIs. And it might not be possible to cache those results or keep them in memory. And therefore, you need to make a call. Now, if you have 2 calls on API or tens of calls, fine, not a problem. The problem is when you have hundreds of thousands or millions of calls. And that's a problem because you need to scale your backend, and the cost of doing that instead of optimizing your design of microfrontends can go through the roof. And this is exactly where you don't want to be. Moreover, the complexity of handling 10 requests per second or 1,000,000 requests per second is completely different. I can guarantee you. And therefore, it's very, very important when you take a decision, you start to think of the effect that you can have on the API or any other layer. Therefore, let's look some possible solutions. So we have these 2 microfrontends, great. Usually, if you are calling the same API, there is a chance, can I say a high chance, that probably are not microfrontends, or better, they are overlapping domain. So an idea is go back to the whiteboard, try to analyze them, try to understand if they are really independent or they must be independent or not. Because it's likely that the answer is go and try to create 1 microfrontend assigned to a team. In the scenario where instead you are seeing that those 2 microfrontends are instead 2 entities that are quite complex to handle, you can work with components. We have seen before, components have, let's say, they are leaking the domain, and therefore there is something, an entity, that in this case is a microfrontend, that can contain the domain, make just 1 call to the backend, and off you go, you have what you are looking for. So the takeaway for this last pattern is trying to understand the end-to-end impact of your decision, because it's very important that we think at the system holistically, despite we are in a distributed team. Distributed teams doesn't mean that you are alone and you take the decision that you want, because you might have an impact to others. And that is quite important that we take a step back, look at our system holistically, and try to figure out what it works. I want to close up this talk with this part on architecture. So architecture is not right or wrong. I've heard so many times developers saying this is the right decision. It might fit your context, but in another context it might not fit. And therefore, bear in mind that architecture, especially modern architecture, is always a trade-off. So when I'm engaging with customers, very often I find myself starting to reasoning loud with the customer and say, okay, so you are suggesting to do in this way, and those are the plus and cons. Would you agree? Yes. Okay, so let's try to evaluate another one, and let's try the trade-off on there. Sometimes, I cannot say always, but sometimes we find that the balance that we were looking for is better in something else and not what they were looking for, because what they wanted to implement is exactly what was working in another organization, therefore another context, with different development teams, different structure, different communication flow, different governance, and so on and so forth. Therefore, remember that when you take a decision that affects a system and not inside your microfrontend, try to find the right balance, try to evaluate the trade-off and try to write them down. There are some techniques like the architectural decision record or RFCs, request for comments, that will allow you to take a snapshot in time of why that decision was made. And that is extremely helpful, especially if you maintain a system for a long, long, long time, because you can go back to that decision, review with your tech leadership or your team and say, yes, that makes still sense after 6 months. But maybe in a year time, the company completely shift the way how they are doing their business, and that decision is completely rubbish. And we are building distributed systems for this reason. We are building distributed systems because we really want to have the agility that before it was complex to have in system that maybe we have to maintain for 10 years, and a lot of developers pass by and quite only few stick around, and therefore it might be a problem. If you're interested to know and go more in deep about this topic, I wrote this post a few months ago around the future of microfrontends. So I spent my December off time, I was in paternity leave, for thinking big and trying to figure out what we are missing. Currently, there are already some threads that I'm working on for the future with a bunch of friends, and I hope to reveal a few of them very soon. So start to take a look on that. That's all I got. I hope that you enjoy as a first talk, and happy to answer any question. And if thanks. If I'm not able to answer all the questions now, I will be around the whole day and tomorrow morning, or if you prefer, send me an email. There is an email. Last but not least, we have an AWS booth here in the conference, where if you have a question on AWS, or if you want to apply any job in one of our Berlin dev teams, feel free to go there, and we are happy to answer any question.
Thank you very much, Luca. So, you still have time to ask questions. You can upvote questions that are already asked. So, let's start. Can you outline your preferred method for MFE to MFE communication? Microphone, Felix? No.
Does it work?
Yeah,
okay,
no.
Now it works. No. Perfect. So first question, what is my favorite communication between microfrontends? So if they are in the same view, usually event emitter or reactive streams, if you're familiar with reactive programming, or custom events that are available in JavaScript out of the box, are three good ways to handle that. Communication between microfrontends across views, there are several. It could be ephemeral. So in the case, for instance, you want to pass an ID, you don't need to store on a session storage or local storage. What you need to do is just passing maybe in query string, like imagine an e-commerce that you are moving from one generic view of multiple elements to the detail page. And in that case, what you could do is just passing the ID of the element selected by the customer in the query string. Ephemeral, you don't have to store anywhere, and then by convention the other team will pick it up and start to load the detail of specific event. If it's not ephemeral and you want to instead store the data like a JWT token, depends from the level of security you are looking for. So JWT might be okay to store on a cookie or a local storage for a bit of more persistence, but maybe you have a stronger security reason. And in that case, probably a web worker could be an idea, because you can store in memory, but you know that the drawback, trade-off again, is that the next time the user has to authenticate again. So you need to find what you're looking for, and between security and user experience in this case.
Okay, thank you. Next question. What is your opinion on multiple micro front ends being developed in a single repository?
Monorepo versus multi-repo. Okay, that's a great question. I don't have a strong opinion on monorepo or multi-repo, and I explain why. When this question was coming up very often, so I started to let's say, gather my experience in both contexts. It depends what you are trying to optimize for. So monorepo allows you to have a lot of discoverability because a new team can see how other teams are implementing certain things, and also allows you to let's say, have visibility of the entire project. So if a new library bubbles up for shared dependencies, great. On the other side, you need to be very disciplined. So you need to maintain your code and bump up your version and try to be aligned on that. And certain teams works pretty well, certain others they struggle with. The other drawback is the CI/CD. When it starts to become very, very large, it might be daunting. And one suggestion usually I have there is trying to let's say, clone only a portion of the project that is doable with the git sparse checkout command that is available in GitHub 2.4, if I remember well. I need to double check the version. But basically allows you to do in a repository with using sparse checkout to just check out a portion of the entire monorepo, so you don't have to replicate the entire repo inside your CI/CD system multiple times per day. That is a problem, and also is time consuming, but you can just have, let's say, an optimized version. But usually monorepo requires more effort in the long run for maintaining a large application. Multi-repo, it's completely different. So there you are optimizing for defining the APIs. So you want to have strong contracts between teams. You don't care on sharing too much. You care on providing a simple way to handle things. But obviously the drawback is discoverability is lacking, because unless you know the repository, and can go very quickly out of hands. Can guarantee you, I was working before for a company called The Zone that probably quite a few people here in Germany knows that. And we have hundreds of developers, and we have thousands of GitHub repositories. So it can go out of hand very quickly. Therefore, the discoverability part definitely will be a problem in a scenario like that. Therefore, I don't have a preference like you see. I just want to suggest, try to understand what you are trying to optimize for and pick the right approach for that.
Time for one last question. What percentage of the time are micro front ends used when they shouldn't be?
Sorry, can you repeat that?
So, how often are micro front ends used when they shouldn't be? So the percentage of the time.
I have seen, as usual, that many developers or companies are trying to use micro front ends, and sometimes, in my opinion, they don't make too much sense, mainly because with distributed system, we are solving a specific problem that is not only independent deployment, but also the fact that you are scaling your organization. The moment that you have a team of 5 people, you can have independent deployments also in other ways. The concept of modularity can be reached in several other ways through design pattern, encapsulation, a bit of discipline of developers. You can even divide by chunks if you're using a specific transpiler that allows you to divide that. So you can reach a certain level of modularity. You don't really need to go to the extreme and move straight to microfront ends. Therefore, I don't believe microfront ends are a silver bullet at all, but we were lacking in the front-end world of something that allowed us to scale with tens of even hundreds of people in the same organization working on the same project. And that is the answer for that need. Now, how many companies are embracing that? Looking at the state of front-end that I took part recently, I think there were on 4,000 developers worldwide, 25% of people that use microfront ends in production. So that tells you already a story. there are certain small teams that they were use microfrontends for because they were developing a SaaS product with customization for customers. Therefore, they want to reuse 90% of the application but customize a specific portion and deploy independently. That is another, for a multi-tenant approach, is another way that you might think about. But that's usually, let's say, the two ways that I've seen: large organization, medium-sized, large organization, and multi-tenant applications.
Thank you so much, Luca. As he said, he's around at the conference until tomorrow. So if you find him here at this dear space, then please ask his questions. Thank you very much, Luca.